Welcome back to Chemistry Online Learning. This is week 4 and we're doing some gas stoichiometry. So as its name implies, it kind of brings together a bunch of concepts from weeks 1, 2, and 3, and we're going to be solving problems like those on the gas stoichiometry practice. I thought I would take this time to do number 27, which brings together a lot of different ideas, and you might want to try some of the earlier problems if you didn't get a great handle on previous week's material before you look at this. If you want to just see the answer in the setup to the stoich, go ahead and skip to the end, but I will walk through this step by step. Okay, so the question asks, how many grams of solid lithium would be added to liquid water to get 15.0 liters of hydrogen gas at STP, standard temperature and pressure. I should make this highlighter bigger. So what you're doing, in essence, is you're trying to go from liters of hydrogen gas into grams of lithium solid. And the problem was nice enough to give you the chemical equation already. So you might remember that from stoichiometry, you should know how to do grams of hydrogen gas into grams of lithium needed. That's a standard stoichiometry problem. Again, you can try some of the earlier questions in the gas stoichiometry worksheet or go back to week 2 to look at how you do that. But now we're doing liters of one into grams of the other. Of course, we've been learning these gas laws, well, I'll start with my given. So, given, I have 15.0 liters of H2, and that's kind of, again, what you're given. You have to start there. There's no other numbers to work with. And what you want, at the very end of the day, is grams of lithium. So I'll go ahead and erase this, since I've already written it out, my given and my want. Okay, so dimensional analysis-wise, and I will be using dimensional analysis to solve this, how would I turn this liters into something that I can actually work with here? Liters of H2. Well, last week, at the very end, after Avogadro's law, we learned that there was an actual conversion factor we can use here. It turns out that 1 mole of any gas, in this case H2, is going to take up 22.4 liters. So this is from week 3. It's a consequence of PV equals nRT. If you didn't remember this conversion factor, you could have said, well, STP means that, well, N is 1 because it's 1 mole. R is always a constant, 0.0821. Temperature at STP is 0 Celsius, or 273 Kelvin, equals some volume at 1 atmosphere. Because, again, that's defined as STP. And then volume of 1 mole is going to be 22.4 liters. That's how I know that. So this is just kind of an aside. Okay, so now my liters of hydrogen will cancel with each other, and I'm in moles of H2. Well, I would like to get to lithium, so moles of H on the bottom, and we learned back in 4.24, I think, mole tunnel, that you can convert moles of one thing into moles of another thing. So how would I figure out how many moles of hydrogen can convert to how many moles of lithium? Again, this information, this is the mole ratio, and it comes from the chemical equation. So according to that, every 2 moles of lithium will make 1 mole of hydrogen gas. So 1 mole of hydrogen gas is produced by 2 moles of lithium. And then again, the moles of H2 cancel out. I'm almost there. I'm in moles of lithium and I want grams of lithium. Hopefully you remember by now that to turn moles of something into grams of something, you just use the molar mass. So again, this is the molar mass. We get that on the periodic table. sorry, I'm abbreviating that PT. So moles of lithium on the bottom to grams of lithium on the top. These two would cancel, and how many grams of lithium are in a mole? Looks like 6.941 or so in 1 mole. And then when you do the whole multiplication out, again, 15 times 1 times 2 times 6.941 divided by 22.4 divided by 1 divided by 1, you should get, I believe, 9.30 grams of lithium. So you need that many grams of solid lithium to be added to the water. Note that in this problem, you did not need to figure out which of them was limiting. You kind of assumed you had enough liquid water to react with the lithium. But you could imagine a slightly more complicated problem where you have also some amount of both reactants and you need to figure out which one's limiting first. Please let me know on Piazza, for instance, if you have any questions about any steps in any of the questions on gas stoichiometry. It can be pretty involved, step by step, but just line up your units, or if you use rice tables, that's also totally fine. But rice tables, stoichiometry, dimensional analysis, that's kind of the theme. Again, the conversion factor you'll often use, not always, but often, is that at STP, 1 mole is a certain number of liters. So again, the key idea from this week is that you can convert between moles and liters. Exactly how many moles are in a liter might depend on your temperature and pressure. So again, PV equals nRT, that's the ideal gas law from last week. You might find that at some P and at some T, so at some P1 and T1, there will be a relationship between the number of moles and the volume. And that way you can convert a moles kind of product or of reactant into how many liters that is, given temperature and pressure conditions. Don't hesitate to let me know if that didn't make sense or remind me of what I left out in this video. I'd be more than happy to answer your questions. Good luck with the assignment this week. All right, that's all for now.